Okay, good morning, sixth graders. Today we are going to continue our study of probability by looking at experimental and theoretical probability. So we've already kind of looked at these two different types of probability. We just haven't really named them yet. So first we're going to start out with some definitions. Experimental probability is probability determined by the result of an experiment. So it is the number of successes over the number of trials. So you're going to do a series of experiments to find your experimental probability. So then theoretical probability is a mathematical way to determine the probability of an event. So this is the main type of probability that we have worked with so far. We've been doing theoretical probabilities of different types of normal experiments you might do with theoretical probability or our simple probability. So theoretical probability is the number of favorable outcomes over our total number of outcomes. So, these are those simple probabilities that we've been working with, the theoretical probability. But now we're going to get more into our experimental probability, and we're going to be looking at comparing the two different types of probability. And we'll be doing this by running trials. So a trial is a single performance of a probability experiment. So we'll be doing trials to figure out our experimental probability. So let's think about it. What is the probability of flipping a coin and landing on tails? So this is going to be our theoretical probability because we're not actually going to flip the coin yet. So it's theoretical. So we know that there's one favorable outcome and two total outcomes. So we have a probability of 1/2. And like I said, this is a theoretical probability. Then let's look at our next one. It says you flip a coin 20 times and it lands on tails 9 times. What is the experimental probability of landing on tails? So we flipped it. Our total number of successes was 9 out of 20 trials. So we have an experimental probability of 9/20, which, as you can see, so the theoretical probabilities for the same event are often not the same, and that's okay. But they are usually fairly close to each other. So 9/20 is only 1 away from 1/2. So our theoretical probability is the probability that something should happen. An experimental probability is the probability that an event did happen. So that is the difference between our theoretical probability and our experimental probability. So let's practice a little bit more. So we're not going to go over the definitions again, but let's look at the 2 examples. It says, John rolled a number cube 15 times and rolled a 6. Rolled a 2 6 of those times. What is the experimental probability of writing a 2? So, once again, we're going to take our number of successful trials. So we had 6 successful trials, and we had a total of 15 trials. So our probability would be 6/15. Then we have our example number 2. Kim made 10 out of 15 shots in basketball. What is the experimental probability she will make a basket? Write your answer as a fraction and a percent. So right now I want you to think about what the fraction would be, and then turn it into a percent. So our fraction would be 10/15, which we can simplify because 5 divides into both of these. So 5 goes into 10 2 times, and goes into 15 3 times. So we know that 2/3 results in a repeating decimal of 6. So to turn our fraction into a percent, we have to move our decimal 2 places to the right. So we can move it 1, 2, and then we can round it, and we can either round it to 67%, or you could do 66.7%. Either of those would be accurate percents. So those are the 2 experimental probabilities. Then we have our theoretical probability, where we are just looking at our experiment and not actually running it. So find the theoretical probability, write your answer as a fraction and a percent. So what is the theoretical probability of picking a blue triangle? So we have 1, 2 blue triangles out of 1, 2, 3, 4, 5, 6, 7, 8 shapes. So our probability of drawing a blue triangle would be 2/8, which equals 1/4, which is 25%. Our next one says, what is the probability of picking a circle or a square? So that doesn't dictate color, so we have 1, 2 circles and 1, 2, 3 squares. So we're going to have 5/8. And in order to turn 5/8 into a percent, we're going to take 5 divided by 8. So 8 goes into 50. 6 times, we get 48. 20, so it goes in there 2 times. We get 4, add another 0, drop it down, and we get a 5. So then we move it 1, 2, and we get 62.5%, or 63%. And then our last theoretical probability is not picking a circle. So what is the probability of not picking a circle? So that's any shape but a circle. So there's 1, 2, 3, 4, 5, 6 shapes that are not circles. So we have 6/8, which equals, divide each by 2, 3/4, which equals 75%. So you have a 75% chance of not picking a circle. Okay, now I want you to do some practice. So it says, write your answer as a fraction or percent and a percent. So Jan tossed a coin 50 times and got 20 ahead 20 times. What is the experimental probability of getting a heads? So then it wants you to give the experimental probability and the theoretical probability. So the experimental probability, we would have 20 out of 50, or 2/5, which equals 40%, because we take our 2 divided by 5. And then our theoretical probability of flipping a coin, or flipping a heads, is 1/2, which equals 50%. Number 2, Stefan hit a baseball 10 out of 30 times. What is the experimental probability that he will hit the ball on the next try? So we have 10 out of 30 times. So we have 10 30ths, which equals 1/3, which equals 33%. And number 3, Henry rolled a number cube 100 times and got an even number 45 times. What is the experimental probability? What is the theoretical probability? So we need to find both again. So we're taking theoretical and experimental. So our experimental, we have 45 favorable outcomes out of 100 times. So we have 45 out of 100, which would equal 9/20ths. And we can get our percent right from the original fraction, which would be 45%. Then our theoretical probability, so if we're rolling a number cube, we have 6 possible outcomes, and 3 of those are even numbers. So we have a probability of 1/2, or 50%. So those are the 2 different ways that we are going to be looking at probability from now on. We are looking at either our theoretical probability, so what should happen, or our experimental probability, what does happen when we perform the actual experiments.